All right. Hello, Twitch. Welcome back. I hope you enjoyed that episode about DynamoDB. And we have with us today on our Databases Deep Dive show, the amazing Joe. Can you tell us your title and what you do at AWS?
I'm just average. You're your average Joe. Name is Joseph Idzorek. I'm a product manager on DocumentDB. I also worked with some fun products like DAX and Elasticache and a few other of our database services.
You may not know this already, but my real name is also Joseph.
Is it really?
It is,
no,
but I had to change it when I became a spy.
Got it.
No,
Okay.
I'm just teasing. So we're going to talk today about DocumentDB. We have a couple questions as well that came in, and I'll answer those at the end. Any questions that you have going along here, I will relay to Joe, or I'll try and answer them myself. But please try and keep chat as interactive as possible. This is your opportunity to talk to some of the best minds at AWS who can answer a lot of questions about everything from data modeling to you can make feature requests. You know, this is the place and the time to get that, you know, virtual FaceTime with the leaders here at Amazon. So thank you so much for coming on.
My pleasure.
I think we should kind of jump into before we go into any slides. You know, one of the things that we talked about in the first episode that you were here for was purpose-built databases.
That's
and
right.
It's kind of a term we keep using and keep driving. And part of the reason for that is in 2019, you know, there are 300 different database engines. Nobody knows what the right one to build and do stuff on is, because we basically, you know, have a different set of criteria for modern applications than what we had for the 70s, 80s, and 90s. And it's a whole new world now. So you have spoken a lot in the past about purpose-built databases. Where do you see DocumentDB falling along that spectrum?
Yeah, so I think, you know, we spent a lot of time talking with customers about, you know, how they're building applications and, you know, what makes them productive, what makes their application scalable and flexible. And, you know, I think we see there's this nice sweet spot within the way that data is handled. And I'll use an analogy, right? So we kind of talk about purpose-built databases in general. I was sitting with a very large car manufacturer the other week, and we were talking about this concept. And they're like, oh, okay, I kind of get it. And I go, well, let me ask you this. Do you use the same engine for every make and model of your car? They're like, certainly not. No, of course not. You know, for this car, we use X. For these cars, we use Y. And we see the same thing with applications, right? They don't use the same database engine for every single application. So DocumentDB fits into that area. And you look at kind of like operational databases of relational and document and key value, that really makes, you know, JSON objects the first-class citizen, the first-class object of the database. And why that matters. And it was kind of fun. I was looking at Strava's public API the other day.
The bike and running.
You got it, yeah, the application. So you can say like, hey, when did my run, you know, start and stop, and, you know, what were the different segments, and what are all the different fun things I do? And it comes out in a huge JSON object. Right, and I look at that and I'm like, okay, cool. I want to, you know, write that to DocumentDB, and it makes a really natural fit because it's already in JSON. I want to persist that in the same format that I'm already using, or that the API already gives me to me. If I have to shred that and have to think about, you know, do I want to put this in a relational database? Now I really have to think about schema, and I have to think about what happens if Strava updates that API. Yeah. And
you know, that brings to mind a point that I think you made the last time we had you on, which is people wrote these huge complex ORM layers to basically deal with that translation from JSON into X format. You know, maybe it was MarkLogic's XML back in, you know, 2007. But
yeah.
you know, moving on from that, you have like your relational database, and you're basically splitting out this huge JSON object into a bunch of different tables, and then having to write another query on the other side when you want to query it and get the data back out. And you kind of made this cool set of animations that showed why we wanted to get rid of those ORMs and instead build something that just naturally maps to those JSON objects.
Yeah, you look at like how, you know, relational database started. The constrained resource was disk and I/O. And if you take that constraint away, it might not be the way that you always want to deal with data. Certainly there's still use cases and plenty of use cases for relational. But when when the data is modeled in the application tier in objects or in JSON, and you introduce, you know, like, hey, I have to shred this apart, these hierarchical structures and complex, you know, it can be very complex documents into something, you know, into rows and tables that are joined through primary foreign keys, that's not something you and I think about doing on a normal basis, right? That takes real work, right? It takes modeling and
if you had asked me
friction.
10 years ago, it was something that I thought about
You
every
didn't
single
have-
day.
because you didn't have this is a great point, because you didn't have too much of an option at that point, right?
Yeah,
Like
that
it's
was-
one of those things where all of a sudden, people are like, hey, I think there's a better way of doing this, right? And I think we could, hey, why don't we just store the data as a JSON object and remove this friction?
I think when Dwight Merriman and Elliot Horowitz were starting MongoDB, that was one of the things they were saying, is they were coming over from DoubleClick, which was this big ad serving company that got bought by Google. And they were saying, what's ridiculous is the fact that we are still doing application level sharding and we're having to build out all of this nonsense for objects that don't really correspond to relational data structures. And we have a quick question from B West here on Twitch that says, it kind of, I think you've covered this slightly, which are, what are the main differences between document stores and key value stores?
Sure. So, and you know this very well because you dabble in them all the time. So when you look at like a key value store, one of the inherent, so we talk about like what's different, what's the same. So key value stores are really good when you know what the use case or the access pattern is when you're starting to develop your application. And the whole point of a key value store is you can horizontally partition that data almost limitlessly, right? Because you're basically saying, hey, I have a partition key. When you go into DynamoDB, that's the first thing you do is you pick a partition key, which is essentially saying, hey, I want to shard my data based on this key. And because we're doing key value lookups, I can horizontally scale that basically forever.
Yeah.
But when you do that, you also make an assumption about the way that you're going to access that data. Now, there's definitely secondary indexes and
access pattern-driven development.
That's right. This is actually a heck of a term. Because you really need to know that. Because if you're saying like, hey, my primary key is X today, but now I have a different access pattern, or I want to use, I don't want to use that key anymore, you need to rewrite the table and you need to rethink about a different primary key.
Your only choices at that point are to create a new global secondary index or to create a new table and add those different access patterns in. Or start changing your application code really to be able to access those things. Whereas with a document store, you can roll in, you can be like DB ensure index on new value, and then you just start accessing it the same way, and hopefully the query planner goes out, chooses the right one, gives you the information back.
Yeah, it's a big difference of saying, I think you have a lot more flexibility in a document database because, what Randall said, you have a query planner, right? And query planner can pick up multiple different indexes. You can use different indexes. You can get rid of them. You can create composite index, multi-key indexes. You can, index arrays or nested documents. You have a lot more flexibility to be able to change the way or evolve the way that you access the data within your database. And then, the query planner can say, hey, I can use multiple indexes to be able to answer very complex ad hoc queries and do things like aggregations and counts and, mins, max, averages, and sums that I can't do on databases that are just doing gets and puts and key value lookups.
Right. That's awesome. Now, we built something called Amazon DocumentDB.
Okay.
Can you walk us through it? Can you tell us about it? And then maybe could you go behind the scenes a little bit and tell us like how the storage layer is working and all this other cool stuff?
Yeah, I think so. Always working backwards from our customers. I think what we heard from customers is that, hey, we really love document databases, but we really struggle with quite a few things, right? And this is how we always think about, what are the customer pain points, and are we adding something that's going to have value to our customers? And we really look at this and say, okay, well, we have a lot of people self-hosting MongoDB on EC2. And they give us a lot of feedback over the years saying like, hey, I really struggle with managing. I'm not an expert in database management. I don't want to be, right? Because that's undifferentiated heavy lifting that I would like to shed. And then the other thing we get a lot of feedback on is scaling. Like, hey, I really wish I could, provision capacity, a new replica instance, or increase my replica size in minutes. I don't want to do it in days or weeks or have to think about a long lead time. That's right. I want to do that in minutes because my business changes in minutes. And then we also had a lot of thing about just high availability and being able to run it at scale, right? And once you get data to a certain size, it becomes very challenging, to be recovered from failures and be able to do replication very efficiently. So we looked at, and even things just as trivial as backup. We have a lot of customers just say, hey, my backup's a really expensive operation on the database that I'm running. I would like to be able to take a snapshot on Tuesday at 12:20 because we're going to do a deployment at 2:00. But because it's such an expensive database operation, that's something I have to plan, and I have to start it, and we have to have an ops meeting.
Locks.
Exactly, and it takes my production database to a grinding halt, and I can set up another replica, but it takes time to set up a replica, and it just becomes a lot of extra work.
I mean, even when you're talking about snapshotting, my previous career was really kind of managing a bunch of these databases, and I remember running it on i3 instances with the NVMe or SSD storage, and so we'd basically RAID 0 a couple of those together, and then we'd say, okay, cool, we're gonna have our EC2 MongoDB fleet. But then when you wanted to copy the data onto a new replica, it became this rsync hell of like, let me figure out how to grab the data files. Okay, now I've grabbed the data files. Now I need to do rs.initiate and get the thing talking from node 1 into the new replica node, and then maybe I wouldn't want it to talk to master, so I'd say, okay, sync from like this specific node, which I know is in Norway and has like no traffic. Sorry, Norway. That's not just not a lot of people there. So it's like you go and that one has less traffic, so you're like, okay, cool, syncing, and then a day later you're like, okay, cool, we're caught up. I can promote this one to master, and now I can, it was chaos.
It's work. Yeah, it's work. And, if we see, we have stories from customers that tell us, they measure the amount of sync time in calendar weeks.
You're kidding.
I don't even measure my vacation in the amount of calendar weeks, right?
Yeah, in hours.
Yeah, it's hours, right? It's hours. So these are the things, these are the pain points that we really took to heart when we thought about making, DocumentDB, and to really make this easier for our customers, to make it scalable and fast and fully managed. And of course, we made it MongoDB compatible because customers love that MongoDB API. It's really the de facto way to work with JSON documents. It's a beautiful API.
I agree with that, but I could be a little biased. Best query language of all time.
It is very nice. So, we kind of look at this and say, okay, well, if we're going to work backwards and we want to solve these problems, how would we do it? And I think if you look at like traditional database architectures, they really weren't built to run in the cloud. Right? They're typically able to run on stuff like this, right? On my laptop or your laptop or on a shared disk instance or on a server on premise. And they really weren't reimagined. They really weren't imagined to run at scale, right? Or at the economies of scale that a cloud can offer. So when we built DocumentDB, we really took that into heart and saying, hey, if we're going to reimagine this for the cloud and we're going to build this on AWS, how would we think about this, right? Would we change things about the way that we architected the database to provide higher flexibility and scale and make it, much easier for our customers to use. So let me fast forward a few slides.
Well, let's look at this slide again.
You want to look at this? Right?
Yeah, because it covers like the core. These are the things that marketing wants us to talk about. Okay. So
then we will talk about
I have to be the
very good man.
Let's cover it.
All right, let's do it. So we look at this and we talk about, and we'll talk a little bit underneath the covers a little bit fast. So DocumentDB, one of the things that we did with it is we don't do full page syncs across for replication or even down to the storage layer, right? We only do logs basically, right?
Okay.
Only log writes. And that's a much more efficient way because usually, one of the constrained resources on a database can be I/O, right? Mm-hmm. How much I/O or network bandwidth. If you're only writing the changes you make to a database down to the storage layer, you can reduce a significant amount of I/O and network bandwidth that you're storing. One of the other things that we do with DocumentDB is we actually separate storage and compute as well. And this is a very key architectural difference that we have.
That sounds like literally every new database that we're building is following that paradigm.
And there's a reason.
Yeah.
There's a reason. I think when you look at like what we've learned from building distributed systems at AWS is you want to decouple things to the most that you can that it makes sense. And reasons why you can do that is they can scale independently. Mm-hmm. They can fail independently. And then we can also do things that can isolate those workloads, right? And one of the nice things about DocumentDB is, well, when you separate storage and compute, and you push a lot of the replication and durability down to the storage layer, well, now the compute you pay for doesn't have to do all that processing that it used to, which frees it up to do more work for your application.
And to your point, this is an architectural discussion that I'm seeing more and more, not just within our company, but also within customers. So I'll go to a customer and you talk about strongly coupled objects, and this is a bit of a tangent, but bear with me. You talk about strongly coupled objects, and there are issues in how you advance those in lockstep. So one of the disadvantages of these strongly coupled objects that isn't often apparent is not just the performance gain, but it's also the migration gain. So I have, an object stored in one location or an object stored in another location, and I can't migrate one system without also migrating the other system. So it makes my deployments more complicated. It reduces the agility of these individual teams to iterate on their projects. So I really I'm seeing more and more this idea of databases as a microservice as opposed to one monolithic and canonical store for the single source of truth of data.
That's right.
And the more that I see that, the more I'm convinced that as an industry, we're moving towards that pattern of databases as a microservice as opposed to these monolithic engines that are supposed to serve our whole thing. Because that's how it used to be. Is like databases were expensive, so we spent all our money on one giant node. And when you decouple these different sections, you kind of get you get a lot more flexibility, not just in the performance realm, but also in the dev life cycle. In the building and deploying life cycle.
Yeah, and developers can then pick the database that makes sense for them. You might have a set of microservices, and one dev team picks Ruby on Rails, and another one picks Node.js, and it can still live.
Those are the two worst possible stacks.
I'm just saying. They could pick those if they so choose, and they could pick a completely underlying database underneath the covers. They don't have to normalize on one particular technology, and I think that's where we see a lot of compromise happen. In application design is one particular dev team either is sanctioned that everybody uses technology X and everybody has to regress to that mean, or the whole company is standardized on foo. And when you get this ability to choose and people are empowered to use what they want to or what they know or what they're efficient with, you get a lot more ownership and you get a lot faster dev cycles versus doing crazy things like trying to build graph databases in an application tier because the database doesn't support it. So
which is something we've done.
Yes.
All right.
Yeah.
So it's fast.
It's fast
and scalable.
Scalable. One of the really things that I is really useful for our customers is architecture. And I spend a lot of time on when we have customer calls talking about hey, I'm just doing dev tests. How do I reduce costs? Well, DocumentDB, because of the separation of storage and compute, storage and durability are handled at the storage layer, right? We always are going to replicate your data 6 ways across 3 AZs. You only pay for 1 copy. But you can have 1 node, 2 nodes, or 3 nodes in a cluster, and you still have 6-way replicated data across 3 AZs. And why this matters is that we don't have this attached disk. So if you want to do just dev tests, you don't need a 3-node cluster. You just need a 1-node cluster, right? And you can actually delete all the nodes from your cluster and your storage still persists because of that separation. So if you're going home on a weekend on a Friday...
Oh, it's like stop, take it away.
Exactly.
It's kind of similar to Aurora serverless.
It's very similar, right? You have the same concepts. And we're not get too much into the debate between what serverless is, but you think about that storage model. It is really, the storage model really is serverless. It auto grows to 64 terabytes, right? When you create a cluster, you don't specify 300 gigs, 500 gigs, and then imagine we're running a company, we have to have an ops meeting every month to look at how much storage we have, right? So we can say, hey, we need to provision an extra 100 gigs next month.
Another tangent. So in the past, if you had to expand an AWS volume and say it was a root volume, the chaos that one went through was you would mount the volume on another instance, and then you would go and you would say, okay, I'm going to resize 2FS or whatever ext4 tool, whatever backend you had, and then you would say, okay, grow this storage. And the amount of times that we had to do that, because we assumed, when we first started an application at this company that I worked at, 100 gigs, we'll never have more than 100 gigs of data. And yeah, that was always the wrong assumption. If you're successful, you often very quickly have more data. So it's a good problem to have.
It is.
But it's not one that you want to manage.
No.
And 64 terabytes, that's almost enough to hold all my selfies.
That would be almost.
Almost.
You had a very active weekend. And the same thing with I/O. You don't go in and say, hey, I need 300,000 provisioned IOPS or 2,500 or whatever the case may be. It's pay as you go, right? So you pay as you go with storage and you pay as you go with IOPS. So then you don't have to think about underutilized capacity or lifting that limit once a month. So it provides a really nice platform from scaling. And then you can add replicas independent of your data size in minutes.
Yeah.
Which is pretty amazing.
It's also really good for dev workloads because if I want to work on a copy of my production data, it's like one snapshot restore. Since the storage is decoupled, I have my node off in one land, and then I say, okay, node in one land, that's separate VPC, separate everything from my other kind of production cluster. Let me try running my change on you. Let me try all the things that I want to try on you, and I don't have to worry about impacting prod at all.
That's right.
I'm so glad I don't have PagerDuty on my phone anymore. Never want to work ops again.
And then we're fully managed, right? So that I think that takes the undifferentiated heavy lifting out of your hands and puts it in our shoulders, which is where we want to be, right? That's what we want to. That's our job. That's our purpose, is to make that so you don't have to do hardware provisioning. Think about scaling, patching, security. There's a lot of things that we do behind the scenes to make your lives easier.
So the other thing I think that's worth pointing out is that the compatibility layer is such that you can use your existing MongoDB tools with no change. Like the only thing you're changing is a connection string.
That's right.
Which hopefully you're loading through Systems Manager, Parameter Store, or through an environment variable, or Secrets Manager, or something. Right. You don't really need Secrets Manager for a connection string, but
at least the credentials.
Yeah, the credentials you can keep over.
Yeah, that's right. So DocumentDB is MongoDB compatible. What that means in practice is you can use the same SDKs, drivers, tools that you use today on, say, MongoDB on EC2, and you can use those against DocumentDB by changing over the application string. Now, in full disclosure, and this is no secret, we don't support 100% of the API today.
I am shocked.
We don't.
It's a pretty vast API.
It's an enormous API. So the approach that we've taken is we're very pragmatic about it. We launched in January with a significant amount of functionality, and then we've just been working backwards from our customers. And we'll continue to do that. We've had two engine launches since then. That I think we added 29 different APIs, operators, aggregation stages. And we'll continue to do that. We'll prioritize what people want the most and what people use. And if folks don't use a particular operator, we don't hear any feedback on it, then we'll start innovating else in other places on behalf of our customers.
So what is the current engine compatibility?
3.6 today.
3.6, okay.
3.6.
So 3.6 has a lot of good features.
Lots of good
and,
stuff.
You might know the question I'm about to ask because I think I ask you this all the time. But one of the things that I would love to see is Geo Indexing. So are you allowed to tell us any top secret info about when we could expect it?
I wish we could. I would just say that we get a lot of feedback from our customers on Geo Indexing and the capabilities and things it can do to build applications.
I would. I'm missing that feature.
It's a very useful feature.
All right. Well, we have. Let's take a side to the Twitch chat for a little second here, and then we'll come back over and maybe we can dive a little deeper on the storage engine and how we replicate things and stuff like that. So we have a discussion going on between Savage Jen and Aerith and a couple other people, and if I could summarize, it's having Savage Jen is responding to a comment I made earlier about how the companies are having more and more different microservice databases, and the Savage Jen is pointing out, perhaps correctly, that when you need to join data across tables, that can be cumbersome. And I think, the one thing that I keep telling customers is figure out a way of representing the data such that a single API call can return the most usable information. So a single query, a single fetch, a single get, whatever, can return the most usable information that you're going to render to your downstream users. That's been my philosophy, and occasionally you have to make some adjustments there just for the purposes of scaling. But if you can return the whole page in one database query, you're solid. If you need to talk to a bunch of different databases to do it, so long as you can do those requests in parallel, and so long as they're scaling at the way they need to scale, maybe you throw an Elasticache or something in front of them, you're getting what you need. And then another point about joining between different databases is with Neptune, which is a graph database, you have this thing called RDF. I don't know what RDF stands for. I assume it's like reference data frame. I just made that up. It is a XML insanity that allows you to take, and this is an open standard that all these different data stores use, that let you store and join objects across databases using a single common schema. And Neptune supports that by default, but you can also store RDF objects in DocumentDB or in DynamoDB or whatever, and you end up merging these by making those queries and using those single globally unique identifiers and those globally unique schemas. So I've seen that. Actually, Siemens Corporate Technology is a company that went and deployed that in prod. So they use DynamoDB, they use Neptune, they use probably 20 other databases, and they use these little RDF schemas and tags to join them all in Neptune to run random queries. And they're okay with the eventual consistency of like, hey, I don't need this data to be up to the date to the second, so long as it's up to the date, every 10 seconds. And that is what they use to drive a lot of their predictive maintenance and their recommendations. And so I really do see this in prod. Like I see this with a bunch of different customers when I go out and talk to them.
Yeah, we also see a lot of patterns of like folks, also combining, like using, I don't know, say, DynamoDB and RDS as operational data stores, and then streaming some of that data to Elasticsearch to be able to do kind of richer full text queries, where they use it's not their operational database, but you use something for it to do analytics or, ad hoc query troubleshooting outside of their operational database, or even into Redshift.
And like some things you need that referential integrity for, or maybe you don't actually need the referential integrity, but the system is working and it's scaling and it has been for 10 years. So why are we changing it? If there's no data pressure on you, if there's no pressure saying like, hey, I need to go to a different data store, then keep it in the one that works.
This is a great point. I love that you brought this point up.
Okay.
Because sometimes not all decisions in databases are 100% rational, right? Like,
yeah.
Sometimes hey, like you joined a startup, your founder used MySQL, everybody in the team knows MySQL, you have a bunch of runbooks that use MySQL, it works for your application. Should you change it and rewrite it to, DocumentDB or Dynamo or something else? Well, not unless there's like a big ROI to do it, right? If you're just doing it for the fashion, then save yourself the time and innovate on behalf of your customers. But if you're there,
differentiate your business.
Yeah, exactly. But if you're there and it's working, then keep on it. But if you're doing things where like every time you add data, the performance of your queries now grows linearly, and then you start to hit business problems, then definitely rethink about it. But just re-architecting for the sake of re-architecting, I think don't do it.
It's a common project when you have interns that you didn't give enough scope to what their project was, and then they finish it in 2 weeks. I'm totally not speaking from experience here. And they're like, hey, figure out what it would be if we moved to DynamoDB. And then occasionally they're like, hey, this would save us $16 million a year. And then they go and do that. Let's talk about the storage engine.
All right, let me fast forward a few pages. All right, so we kind of talked about this a little bit before. Like, hey, what would you do if you're going to re-architect a database for the cloud? From the things that we've learned, the things that we know, what would we do differently? And we'll talk about each one of these, right? So we decouple storage and compute, right? Monolithics, they're challenging in databases just because of recovery time and scaling, right? When you have to do all that syncing of data all over the place, it's a function, it's physics, right? It takes time to replicate all that data. Also, distributing data in smaller partitions, if you will, right? Instead of having like large, 1 terabyte shared disks, because if that thing fails, you got to copy over a terabyte of disk. If you can reduce those into smaller sizes, it really helps with mean time to recovery, and then increasing the replication size for data availability and durability. So let's talk about each one of these. So with DocumentDB, essentially what we've did, and I'm simplifying this quite a bit now, is we separated basically the API parsing, query processor, and caching functionality of a database engine into the compute layer. Oops. Right, that's your compute layer. This is basically what an instance does.
Okay.
And then we've offloaded a log of the logging and replication into the storage layer, right? And within DocumentDB parlance, this would be your storage volume, right? So it actually takes a lot of the work that used to happen at the database or the compute layer and puts it down into the storage layer. Again, frees it up to do more work for you. And this allows each one of these layers to scale independently and decoupled from each other, which is very nice.
So this is more advanced than mim-mapped files.
It's a little bit. It is. It's real work. Like this is real work, and a lot of smart people worked on a lot of this technology for many, many years to make this possible. So the other part is distributing data into smaller partitions, and why that helps. It helps to be able to do things like mean time to recovery, and we'll get to We'll get to a slide that talks about that. And then we also do, partition the data across we partition the data across the storage volume, replicate it 6 ways across 3 AZs.
So 6 different copies of your data.
6 different copies. And we ACK it by default with DocumentDB. So it's durable by default. We ACK it after you get back when you write 4 times, right? So you've already written...
So when the majority has...
Exactly.
So when you have quorum of this
6.
many nodes have agreed that it's been written to disk,
That's right.
or I guess journal or whatever, then it acts. And so I've done writes to DocumentDB, and it actually responds in perfectly, sub 10 millisecond time frames.
That's right.
How?
Magic. No,
Sorry,
magic.
sorry,
but it happens. But when you're only doing writes, right? You're actually only doing writes, and you're only writing the delta, the changes, and then you have the storage layer that does a lot of the heavy lifting for you. In addition to the compute layer, right? You get
It's like a multi-threaded process going on in the background, and it's like saying, okay, boom, boom, boom. We're gonna talk this many nodes. We're gonna like aggregate the result. Boom, you get a response.
Yeah, and you're also distributing across the distributed storage fleet as well. But the thing to note is it's by default, right? It's durable by default. You don't have to do anything within your connection strings to be able to say, hey, I want a durable write, right? Because I think, when we have to change things out of the defaults, then, if you don't change the default, then sometimes you can get in trouble.
Yeah. So the MongoDB default, if I remember correctly, and it's been a while, it's like write concern of acknowledge the right to journal across whatever node you're talking to. It's not... But the thing with the MongoDB connection strings or the MongoDB drivers is you can say, okay, I have a read concern of majority and I have a write concern of majority, which says I only want to read things that are consistent across n number of nodes, or I only want to write things that are consistent across an n number of nodes. And when you have geographically distributed nodes, like say one in US East 1, one in US West 2, and you're trying to talk between those, the latency can go up quite a bit. Like you can have 100 milliseconds plus of replication lag depending on your setup. Some normally less, right? But it becomes cumbersome to scale all of these different nodes with each other, and they also have to be at least as big as the one with your biggest traffic.
That's correct.
You can't have outsized nodes because then they can't keep up with replication lag. But the way that this works is within a single AZ, it's saying by the time you get an ACK from us, there are 4 different copies of your data stored. So that protects you against this like n+1 failure.
That's right. So let's talk about that because that's important. Let me fast forward. So when you think about recovering from failure, let's just imagine a really bad day in AWS land. And this is your database, right? So the green just represent one copy of your data. The orange represent a second copy of, just say, like one particular document, right? Okay. So we have 2 different documents that are replicated 6 ways across 3 AZs.
Okay.
And let's just say a really bad day in AWS land happens, and we lose an entire AZ, right? Well, in this architecture with DocumentDB, whether you have 1 compute instance or 7, your data is you still have 4 copies, right? So you still have a write quorum, which is great. And you still have read quorum, right, for anything that above majority. So you still have a fully accessible database, even though you've lost an entire AZ. That's pretty good.
Yeah.
But
we can do that. We can do that in EC2.
You can do that in EC2, right? So, but the challenge really now comes in and saying, just because an AZ went down, there's not a non-zero probability that you could lose a storage node on a different AZ and a different,
Everything fails all the time.
Exactly. Everything fails all the time. Warner, I think, has made this very clear to all of us now, but I hope he keeps repeating it. So let's just say this scenario happened at the same time.
This is like single EBS volume failure in the EC2 model.
That's right.
Okay.
Exactly. Single AZ goes down and single EBS volume fail
in
happens.
Another AZ.
So in a traditional database, if you didn't have this, you would basically have lost 2 copies of data, right? You would have lost 1 AZ, which was one of your nodes, and then you would have lost the second node, right? So then you would be down to a single instance, which is bad. That's bad. Usually when that happens, that's when you have scenarios of data loss, and you have full unavailability.
And that is when my PagerDuty
alarms
start going off.
For your birthday, I think I'm going to get you a subscription to PagerDuty, which was just last week. So
absolutely no, no. I deleted PagerDuty from my phone in 2016, and it is never coming back.
I think I will start a campaign on Twitter.
No.
But so what is really nice about this with DocumentDB is that if you look at, if we look at 6 copies across the AZs, we lost 2 because of the AZ failure. We lost 1 because of the random node failure. So we have 3 replicas of our data. We can still read from the database, but we can't write, right? Because we don't have a quorum.
Yeah.
So what really matters now is how fast can you recover, right? It's not so much the failure did happen. Now it's mean time to recovery. Well, if you have 10 gigabyte chunks and you have a 10 gigabyte link, that's seconds, right? It takes seconds to transfer that data over, and then you're back to a write quorum. If that's 4 terabytes, that might take a really long time, right?
But I think we have faster than 10 gig links.
So it's even faster than 10 seconds.
Oh.
So then it's really fast, right? So yeah, exactly. So you look at the backplane, and depending on what it is, it's much quicker. The mean time to recovery is much, much faster when the data's smaller. So that's what it helps to be able to partition data into smaller pieces. And then you're back to write quorum. And when that AZ comes back online, you might not even have known from your database perspective that it was down at all.
Do we throw things in the logs if anything like this ever happens?
Oh yeah.
Okay.
We know when this happens.
I've never actually experienced.
Oh,
this,
do we throw it back? I don't think we'd ever throw this. You would know that an instance went offline, but you would never know that the storage.
Okay.
It would just and this is one of the beauties of a fully managed service. Unless it affected either your read or write availability, you would never know the difference. We would just handle that behind the scenes.
All right, we're gonna do a brief interruption here to take some questions from chat.
All
right. So Irreverent Q, who is my friend Nolan from New York City, the greatest city in the world, says, "Happy birthday!" And also, what resources do you have to help get newbies up and running with DocumentDB? I think this could be a good resource because maybe we could just show like how to provision a cluster and everything.
Yeah, let's do that.
So I'll let you get that set up, and then we'll do another question while that's going. So Kitch X3 and Erithus, these both sound like Elvish names. So Megovanen and Lord of the Rings nerd. Anyway, they point out, perhaps interestingly, this model looks a lot like the model on Aurora. Huh.
All right, so let's do that one first, and we'll go through here. So when you look at a lot of the challenges that customers had on MySQL and regular PostgreSQL moving to the cloud, I think there's a lot of similar feedback on kind of monolithic database architectures and kind of the pain points that people struggle with trying to self-manage that. So when it makes sense, we definitely re-leverage architectural designs and technologies to be able to bring that particular capabilities to customers. So
I foresee a lot of different kind of models being built onto that. And then finally we have a question from DeFly45, which is, do you know off the top of your head what percentage of the MongoDB API is covered at this point? I know we have a page that outlines that.
Yeah, I mean, I think there's kind of 2 parts. There's like the absolute number and count, and then there's what folks actually use. And a vast, vast majority of what folks actually use, we cover. And I get this feedback, every day from the field and from customers, across all the folks that we deal with. And it's a vast, vast majority. And we're working right now to close the difference on the ones that people care about.
All right, I'm gonna paste the little limits page for you to fly. And now maybe we can hop over to your screen and we can see provisioning a cluster. So a Reverend Q can learn how to get started.
That's right. And we also have this in the documentation. I also filmed like a little 2-minute video of me going through this for folks that want another resource offline. So within the AWS console, we can go into DocumentDB and we find it there. And very similar to other consoles that we've dealt with in AWS, I have a couple clusters that have already been created. And I'm going to create a cluster. And just kind of in the nouns and verbs of what within DocumentDB, a cluster is essentially a namespace and a storage volume. And then within a cluster, you're going to also create instances, right? And that's really that separation of storage and compute.
That's an important point.
Yeah, so you can have a cluster that has 0 instances, or you can have a cluster that has 15 instances. So this is, so we'll go ahead and create one. And we'll kind of talk about some of the choices here. So we now have R5 larges everywhere, or R5 instances everywhere, which is great because they're maybe up to 100% better performance than R4s. Same cost, not a price reduction, but more value.
We did technically that is a price reduction because you're getting more performance out of it. Yeah.
Better.
No, we did a quick analysis a couple weeks ago of the difference between R4 and R5, and it was like 100% double improvement essentially. That surprised me because the processor are not that different. It's just like, I guess we added faster RAM or something. I don't know.
The combination of it all together, it's magic. So when you provision a cluster, right, you can predict the number of instances you want. If you don't have any instances, you're not going to be able to query. So at least we're going to kind of make you have one instance. And then you can create a username, right, and a password. And then we have some advanced settings. Ooh.
What's the password?
I can't tell you because I reuse it. So here's a couple of things to think about when you're creating a new cluster. There's these concepts of VPCs and security groups, right? And this is where we see a lot of questions around. So it's good to clear it up because security always gets in the way with usability. By default, we'll provision a cluster within your own VPC, your default VPC. You are welcome to change that, right? You can change it to a different VPC. But when you go to connect to your cluster, you want to make sure that your client is in the same VPC. Right. Yes, you can do VPC peering or you can do SSH tunneling, but that's a little bit more work, right? You can do it, but usually you want to put your instance, especially for doing dev tests and getting started, in the same VPC as the cluster that you're deploying.
Yeah, SSH tunnel isn't that much work. It's like SSH-L and then port.
And we do have that in our documentation as a guide.
Can you connect through anything like the system? Like, can you connect through the console at all?
There is a really cool service called Amazon Cloud9.
Yeah. Oh, right.
That's right. Which provides, we see a lot of these scenarios where people say, hey, my company won't allow me to open a connection on port XYZ. Yeah. I need a console-based experience. So what the console or Cloud9 allows you to do is get basically shell access in the console. And then you can install Mongo Shell, and then from the AWS console be able to manage or query or poke around on your database, which is super useful and demos really well. Next time I come on the show, I will demo that.
I probably really like should have remembered that because I just wrote a tutorial about how to do that.
So yeah, it's really nice for an in-browser query experience. And there's really no better way to query than with the Mongo Shell, right? It's really nice. All right, so security groups is also important, right? What is a security group? It's a firewall, right? It's basically saying like, hey, for this cluster, I'm gonna create a firewall around it, and then you can control what the inbound traffic is, and also what is the outbound traffic.
And security groups can be self-referencing, so you can add nodes that are allowed to talk to each other by just adding yourself into that security group. So that's what you do commonly in a lot of these VPCs is you'll say, hey, any node, any instance that has this same security group on it is one that I'm going to allow to talk to the database.
That's right. And this is important because by default, so we see that the default port for DocumentDB is 27017. If your security group doesn't allow inbound from either say the same security group, the same VPC, or on this particular port, the firewall or the security group will block access to that, right? And that's an important point. So depending on how you set up your security groups, if you have a timeout in your connection, usually it's because you don't allow inbound on 27017. All right, so a few things. Encryption at rest and encryption in transit are enabled by default.
All right, we might want to hold off for just a second here. I think we're having a technical issue waiting on our amazing producer in the back there to confirm if we are still streaming. So in the meantime, before we convey any more of this delightfully interesting content, tell us what your favorite pet is.
If I had a pet, my favorite one, I think it would be a monkey.
A monkey?
I think a monkey.
A chaos monkey?
Not a chaos monkey. I think I have this memory. All right.
Okay, so I think we're back. Okay. I think it's working again, so we can continue. Sorry about that, everybody. Not sure what happened.
No worries. So just going through the advanced setting, encryption at rest and encryption in transit are enabled by default. You can turn those off, but you have to do it, not us. Backup is enabled by default, right? So you're going to get a day's worth of point-in-time restore backups, essentially for free. Because we're going to give you up to the size of your database. Say you have a 300 gigabyte database for free for storage a month. So this is really nice. You can't even turn backup off on DocumentDB. You get 1 day. We make you have 1 day.
That's good.
Because it's the right thing to do.
How far can you extend it out to again?
35 days.
35 days.
So you get 35 days of point-in-time restore capability.
Nice.
Logs, maintenance, all the fun stuff, and then we create. Now, I've already cooked this turkey ahead of time, so to speak. So let's go ahead and look at a cluster we've already created. Now this cluster has 2 instances. Right, so they have these 2 instances. has a writer and a reader, right? And I can delete them, I can add more. We're all good to go. One of the things we do within the console is we make it easy to connect, right? So we can take the Mongo shell connection string, right? And we can go over to an EC2 instance. EC2 instance is in the same VPC, and I already have my security groups all ready to go.
Do you have to do anything with like SSL or TLS or anything like that?
So we have two different options, right? This is with TLS enabled or disabled.
Wise choice.
Right? We can have it enabled or disabled. We have instructions on how to do that. It's enabled by default. And we also have examples on how to connect programmatically from different languages, C#, PHP, using both TLS and non-TLS.
Why do you keep throwing out these like terrible languages? You've said Ruby, you've said JavaScript, you've said PHP, like C#. Like, there's only one language that we want to use here, and it's Python.
No. We will do nothing in Python. We will only, pretty soon we will, PHP for
Oh, boy. Yeah, okay, yeah. Let's move on before we get into fighting words.
I will not, I do love Python, but I will purposely omit it for your purpose.
All right.
Right, so then we can connect, right, and we can...
Use the password hunter2. And then,
right, we can get access to our database.
All right.
We can do a db.foo.insert. Oops, can't type.
Hello, with a W.
Right. Right, we can insert that, and we can do redo find.
Awesome.
Oop, and I fat fingered it. Right, and so we can read and write to the database, and it looks just looks like we normally would expect it to look at the Mongo API. So that's really quickly on how to get started with DocumentDB. Again, we have a tutorial. We have a video that I shot. We also have some troubleshooting steps in case your client's in a different VPC, or you have a security group that's enabled that doesn't allow inbound.
So I mean, getting started is essentially provision the instance, connect to the instance.
That's right, and you're off to the races.
Oh, okay, that's pretty good.
And you're off to the races.
And just to give a Reverend Q one more question here, what other resources? What's a good place to point someone at if they want to get started? A tutorial they can follow or something like that. Just the docs?
Yeah, the docs. We spend a lot of time on the docs. As it's kind of it's a large source of information, but we spend a lot of time. Also, the docs have the ability to give feedback. So if something's not clear, or something we can improve in, definitely give us feedback in the docs. Every time that happens, I get a ticket that goes right to my inbox. So if you want to say hi or you want to give feedback, that's a good way to do it.
All right, so I'm just going to check to see if we have any other questions coming in from the stream. Nothing that's relevant to DocumentDB. All of you in Twitch chat, we've got about 5 minutes left. I more than welcome all of your questions. I'm going to throw a couple questions over here.
Let's do it.
So let's say I want to run an aggregation pipeline.
That's right.
There's the storage layer, and the storage layer is separate from the compute layer. So one of the things that we do in aggregations is we often will be joining disparate collections, or we'll be combining or searching disparate collections for some value in one to some value in another, which is really just another way of saying join. But can we parallelize those things out to the storage layer? Does it know that it can do that, or is that an optimization that isn't quite made?
So these are or
can you not tell me?
Yeah, no. So I mean, in general, so the way that DocumentDB works right now is we use obviously the memory within the instance to be able to do, pull all the pages, and we also use local disk as well to be able to do sorting and different things related to that working set. But I guess, what you're generally asking about is, hey, can we, and this is just a good general principle in databases anyways, is can we push more of that functionality down into the database so we can put it closer to where the data lives, closer to where actually the storage is. Yeah. This kind of reminds me of Hadoop all of a sudden.
Yeah.
Can we bring the compute closer to the storage?
Can we run our MapReduce jobs just entirely in one database?
Yes, we can.
Yeah. Okay.
Yes, we can. No. And those are always things that we're looking at and adding and providing, a better experience, faster performance is can we push that stuff further and further down into the database and make it more efficient, use the resources better. So those are things that we'll absolutely be looking at.
And I think another kind of cool component is to figure out how you can do the different locking components, because I remember way back in the day dealing with writing some of these storage engine components. We had to really think through the giant matrix of complicated locks that you would have to acquire and unacquire. And I never want to do that again.
Yeah, I was reading a blog last night on isolation and consistency levels, and it's definitely complicated. When you get in the nitty gritty, and that's why safe defaults are very important within databases, because a lot of people won't spend the time or don't think to spend the time to change a lot of the defaults with isolation or concurrency or durability to get past what the default option is, and then you only really learn about those things after something bad goes
well. Since we're public and since this is going to go out to the internet and everyone's going to see it, I'm going to add in one more time my feature request for Geo. I'm sorry. What you don't know is after the stream, Joe is going to punch me in the face.
No. I've been getting this feedback from Randall for a long time, but I always noted definitely it's something that we do get a lot of feedback from our customers.
Rocker Boo from the Twitch stream says, I second Geo. So, motion is accepted.
Motion accepted.
And
stone.
So I think we're gonna close out here,
cool.
And what I'll do is I'm gonna just give you the next schedule for a couple weeks. So next week we will be presenting live from Remars, which is the giant conference that we're throwing in Vegas, where there are a bunch of actors and Jeff Bezos and all these other people talking about robots and Mars and space exploration, all this other stuff. And we are gonna throw the databases show from there. So we also have, in about 1 minute, another show happening based on the amazing painter Bob Ross. Is that his name? The Happy Little Trees. So this is going to be Happy Little APIs. So you're going to have this amazing little demo of Happy Little APIs coming up later. And we're going to kick it over to them. And thank you so much for joining us yet again. We're going to be back next week at Remars. Thanks, Joe.
Appreciate it. Thanks, Randall.
See you next time.
Thank you.